class of Technomathics. So today we will be taking some questions where we need to find the area of the shaded region. Okay. So to just solve such questions, what are the steps which need to be followed? Let us see, and we will just solve two questions which we have taken for today's session, right? So here in the first question you can see OACB. OACB is a quadrant of a circle with center O, right? Now we need to find the if the radius of this quadrant is given to you and the radius is equal to radius is given to you, that is R, which is equal to 3.5 centimeter, right? So where is 3.5? 3.5, this is the radius. Okay, so that means this will be the radius. Though this figure is not as per a scale, but as it's given that OACB is a quadrant, then OA will be equal to OB, right? So here this is also equal to R, right? This is also equal to R. Now, because it's a quadrant, you know what is a quadrant? Quadrant, a quadrant is a figure whose three sides are covered, okay, and two of its sides are with radius and one side from the arc or the circumference of the circle, right? So here you can see OACB. You can see this circumference, this perimeter. This is a this is a quadrant, right? Now it's given that if OD is equal to 2 centimeter, so a new data is given to you, that means the length of this OD, right? So OD is another data which is given to you, and that is equal to 2 centimeter. So this is equal to 2 centimeter, right? Now into this figure, the another data is given to you is OD, which is equal to 2 centimeter, right? Now find the area of the quadrant OACB. OACB. So what is the area of that quadrant? You know the area of a quadrant OACB is given by the formula theta by 360 into pi r square, isn't it? Now we are knowing the value of theta because you can see by observation this angle is equal to 90 degree. Since this angle is equal to 90 degree, just put up the value of, in place of theta, put up value of 90 by 360 into pi r square. You get the value of the area of the quadrant, that is 90 by 360 into pi. Pi is asked to be taken as 22 by 7 and r square. So r is given to you as 3.5. So this is 3.5 into 3.5, right? So this will be solved very easily. After that we will be finding the area of the shaded region. Okay, so before that let us solve this. After replacing decimal, this will be 10 into the denominator. After replacing decimal, this will be 10 into the denominator, and 90 in 4 times is 360, right? And 7 in 5 times 35, right? Then 4, and again 7 in 5 times 35, then 2 to 4 to 11, right? So 11 into 5 into 35, this will be given by 11 into 5 into 35 by 200. So I think you can easily solve it, students. Okay, so just find out this area. This will give you the area of the quadrant. Okay, I will not take that much of time. Now let us find the area of the shaded region. What is the area of the shaded region? That is more important to you. Okay, because it's very difficult after looking the picture how we will be solving it. Okay, so here you can see already we find the area of the quadrant, right? Area of the quadrant we have already calculated, that is this much, right? It's a simple calculation, you can follow it, right? So So this is the area of the quadrant which is known to you. Now from this area of the quadrant, if you subtract the area of this triangle, this one, then you can easily find out the area of the shaded region, right? So let us do one thing. From this area of the quadrant, whatever we have calculated, just subtract the area of the triangle. But what is that area of the triangle AOD? Area of the triangle AOD is how much? It is equal to, how will we apply the Pythagoras? No. It's a simply, you can see it's a 90 degrees. So half into base into height, right? So this will be given as half into base. So base is the radius of that quadrant. So half into radius, that is, what is the value of r? That is 3.5. And this is the height of this triangle. That is, it's given that OD is equal to 2. So put up the value 2. So 2 and 2 will be cancelled out, and 3.5 centimeter square, 3.5 centimeter square is the area of the triangle AOD. Now what you will do, area of the quadrant minus area of the triangle will give you the area of the shaded region, right? So the area of the shaded region, so shaded area is given as what? Area of quadrant, right? Area of the quadrant, and subtract the minus area of the triangle. This will give you the shaded area, right? And what is the area of the quadrant which we have calculated? That is equal to 11 into 5 into 35 by 200, right? So 5 7 times 5 40, 5 8 times, so 77 by 8 minus area of the triangle, that is 3.5, right? So this will give you 77 by 8, so that will be 77 by 8 minus 3.5, this will give you 8 9 72 50, 8 5 45, 9.55 minus 3.5, so this will give you around 6, right? So 6 centimeter square is your area of the shaded region, right? I hope you get it. Now we will take the second question for today. So before going to the next question, I am quickly summarizing. To find the area of the shaded region, we find the area of the quadrant. That is by the formula theta by 360 into pi r square. We find out the area of the quadrant, and from the area of the quadrant we subtract the area of the triangle. But to how we will calculating the area of the triangle, this will be equal to half into base into height. AO is known to you and OD is also known to you, right? AO is the radius, the value is 2, and OD is given to into the question, that is 2. So subtract this area of the triangle what we have calculated, that is 3.5 centimeter square. Subtract this from the above one, from the quadrant, you will get the area of the shaded region, right? Now coming to the second question. This is the second question in front of you, right? I have already drawn a picture before coming to the live session, so that's why it become easier for me. So into this question it's given that ABCD, A is a square, each of whose sides is 28 centimeter. So the length of these sides is given to you. This square is 28 centimeter, right? So we can write AB is equal to BC is equal to CD is equal to AD. Why? Because all these sides are the sides of a square, and all sides of a square are always equal. So this is given to you as 28 centimeter, right? Now after this, what is the data given? Find the area of the shaded region. Take pi equal to 22 by 7. So nothing else is given to you. Now we need to find the area of this shaded region. So to find the area of this shaded region, what we will do? Let us see. Here you can see the angles which is formed by the square. All the four angles of the square are of 90 degree, isn't it? Tell me. 90 degree. So since all angles are 90 degree, right? Since all angles are 90 degree, so we can see four quadrants are forming, right? So when we calculate the area of the square, the complete square, it's very easy. 28 into 28, that is the area of the square, that is equal to side square. So area of the square is given by side into side, that is equal to 28 into 28 centimeter square. So area of the square is known and is now calculated, that is ABCD, but we have to find the area of the shaded region, mind it. So to find the area of this shaded region, what we can do, we need to subtract the area of the sectors from this. So there are four sectors, right? This is sector number 1, this is sector number 2, this is sector number 3, and this is sector number 4, isn't it? So four sectors when joined together, okay, the total area whatever it will be coming, when you subtract it from 28 into 28, you will get the area of the shaded region, isn't it? So we know the area of the sector is theta by 360 into pi r square, and one of this angle theta is 90 degree, and this is coming four times. So all these four sectors, when you are just putting together all these four sectors, let us see when one sector is kept like this, right? Another sector is kept like this, right? And third sector kept like this, and fourth is kept like this. Then here you can see all this arrangement. If this is sector 1, you can see if this is sector 1, right? And after this is sector 2, right? And this is sector 3. You can see the curve is down, and here also the curve is down. And if this one is sector number 4, then you can see all this 90, 90, 90 and 90 will add to form 360 degree, right? So that means all these four sectors 1, 2, 3 and 4 will combine together, and combined area is the area of the circle. This is the area of the circle, isn't it? Tell me. If this is the area of a circle, then it's very easy to calculate. It is not required to find the area of the first sector, second sector, third sector and fourth sector. But just applying this concept, you just combine all the sectors together. You can see a circle is forming like this. If this is sector number 1, you can see the curve is upward here. And this is sector number 2, the curve is here. You can see, right? And after that curve 3 here, this one, and curve 4 here. So this all will be forming a circle, right? So from the area of the square, if you subtract the area of this circle, what is the area of this circle? This is pi r square, that is pi into r square. So what is the radius of this? If this is 28 is the side of the square, you can see its symmetrical diagram. So we will be considering this radius as 14, because 28 by 2 is 14, right? Hi Saini Pulkit, hello. Oh great, you calculated it. Fine, let us solve, then we can match the answer. So pi into r square, that is 14 square. So 14 into 14 centimeter square is the area of the all four sectors 1, 2, 3, 4. I'm now writing the words. Okay. So here pi is 22 by 7. So 22 by 7 into 14 into 14. So this will be giving you 7 will cut this 14 two times. So this is 22 into 28. So the area, complete area will be like this. Let me shift a little. The area of the square was 28 into 28. This was the square area. And subtract from here the area of this circle. What is the area of this circle? This is 22 into 28. And this is the area of circle. And this will give you the shaded area. Isn't it? Shaded area. This will give you the shaded area. Now, here 28 can be taken as common from both, right? So if 28 is taken as common, then if 28 is taken as common, then inside the bracket we are left with 28 minus 22, isn't it? So this will give you 28 into 6, because 28 minus 22 is 6, right? This much of centimeter square is the shaded area, is this shaded area, right? 28 into 6 centimeter square, which will be giving you 6 at 48, carry 4, 168 centimeter square. 168 centimeter square. So Shiny, you can just put up your values, 28 square minus 196.5, that will also come to that. Okay, you can match your answer, right? So in this way we find the area of this shaded region, and that to 168 centimeter square. Solve this question, right? So I hope you understand the concept lying behind, students, and how these four quadrants will be forming a circle, and why this circle area is subtracted from the area of the square. Absolutely, to definitely to find the area of this shaded region, right? So thank you so much for watching, students, and take care. Happy learning. For any query, you can put up into the comment box your doubts, anything. I will take it up. Thank you. Bye bye. Take care.